The High Availability Challenge. Welcome to the channel. Please consider subscribing and hitting the bell icon so you get notified of new videos. Today we are going to dissect a very common and important exam topic: configuring Google Cloud's dedicated interconnect for high availability. The question before us presents a specific, high-stakes requirement of achieving 99.99% availability for the network connection between an on-premises data center and Google Cloud. This 4 nines level of availability is the gold standard for mission-critical enterprise workloads. It translates to less than an hour of potential downtime over an entire year. Achieving this requires a very specific, redundant architecture. The question also adds a key constraint: we must keep the cost minimal. This means we can't simply over-provision everything. We must select the precise minimum set of resources that satisfies Google's official service level agreement, or SLA, for this level of service. Our task is to select 3 correct options from the list provided. Understanding interconnect SLAs. Before we can analyze the options, we must first understand how Google defines availability for cloud interconnect. There are 2 primary SLA tiers, and the choice between them dictates the entire architecture. The first tier is 99.9% availability, often called 3 nines. To achieve this, you need a redundant pair of VLAN attachments running over a single dedicated interconnect connection. This protects against the failure of a single VLAN attachment or a single piece of equipment on Google's side within one router, but it does not protect against a failure of the entire interconnect circuit itself. The second, higher tier is the 99.99% availability that our question demands. This 4 nines SLA requires a much more robust, fully redundant topology. It is designed to protect against the failure of an entire physical interconnect link, and even the failure of an entire Google Cloud Edge location. Understanding the specific components of this topology is the key to answering our question correctly. The 99.99% topology, physical layer. Let's examine the specific physical requirements for the 99.99% SLA, according to Google's official documentation. This is a non-negotiable blueprint. First, you must provision at least 2 separate dedicated interconnect connections. These are the physical fiber cross connects that link your on-premises network to Google's network edge. Critically, these 2 connections cannot be in the same place. They must terminate in 2 different metropolitan areas, or metros. For example, one connection might be in Ashburn, Virginia, while the other is in Chicago, Illinois. Furthermore, within each of those metros, the connections must be made to 2 different Google Cloud Edge Availability Domains, or EADs. This ensures that a local failure, like a power outage at a single colocation facility, cannot take down both of your links. This physical diversity is the foundation of the 4 nines guarantee. The 99.99% topology, logical layer. Building on top of that physical redundancy, we have the logical layer configuration within your Google Cloud VPC. The physical interconnects are just pipes. The VLAN attachments are what carry the actual data for your projects. To meet the 99.99% SLA, you must create a minimum of 4 VLAN attachments in total. You need to create 2 VLAN attachments for the first interconnect connection in the first metro, and another 2 VLAN attachments for the second interconnect connection in the second metro. This provides redundancy at the attachment level on top of the physical link redundancy. These VLAN attachments must then be associated with cloud routers. To maintain full redundancy and avoid a single point of failure in the control plane, you must use at least 2 cloud routers. Typically, all VLAN attachments in a given region are connected to a single cloud router in that same region. Since your attachments are in 2 different metros, they will almost certainly be in 2 different Google Cloud regions, thus requiring at least 2 separate cloud routers. The critical role of global routing. Having a redundant physical and logical path is only half the battle. Your virtual private cloud network must be able to intelligently use these paths. This is controlled by the VPC's dynamic routing mode. Because our two interconnects terminate in different regions, we must set the VPC's dynamic routing mode to global. With global routing, a cloud router in one region can advertise all of the subnets within the entire VPC, not just the subnets in its local region. More importantly, it allows the VPC to learn routes from on-premises via cloud routers in any region. If we were to use regional routing, the VPC would only learn on-prem routes from the cloud router in its local region. If that link failed, the VPC would have no way to automatically fail over and use the second link in the other region. Therefore, global dynamic routing is a mandatory prerequisite for the 99.99% interconnect SLA. Configuring the components via gcloud. Let's look at how we would configure some of these key components using the gcloud command line interface. While the interconnect connection itself is a physical process, the cloud routers and VLAN attachments are configured as software resources. The first command on the slide creates a cloud router. We use gcloud compute routers create and give it a unique name. The network parameter specifies which VPC this router will serve. The region flag is crucial. We would create one router in the region for our first interconnect, and a second router in the region for our second interconnect. The ASN parameter sets the BGP autonomous system number for the router. The second command creates a single VLAN attachment. We use gcloud compute interconnects attachments dedicated create. The router flag links this attachment to one of our newly created cloud routers. The interconnect flag specifies the physical interconnect connection this attachment will run over. We would repeat this process 4 times to create our required 4 attachments. Evaluating the options. Now, armed with a complete understanding of the 99.99% topology, we can evaluate each option from the question to determine the 3 correct answers. The option for at least one cloud router is incorrect. The topology requires at least 2 for redundancy. Regional dynamic routing mode is also incorrect, as we have established that global routing is mandatory. At least 2 VLAN attachments is insufficient. This configuration only provides a 99.9% SLA. We need 4. This leaves us with the 3 correct options. Global dynamic routing mode for VPC networks is correct and mandatory. At least 4 VLAN attachments is correct, as it is the minimum required for the logical redundancy. Finally, at least 2 cloud routers is correct to ensure control plane redundancy across the 2 different regions where our interconnects are located. Summary and final answer. We have thoroughly analyzed the requirements for achieving a mission-critical 99.99% availability SLA for a dedicated interconnect connection. We've seen that this requires a carefully designed, multi-layered approach to redundancy. This involves physical diversity with 2 interconnects in 2 different metros. It requires logical redundancy with 4 VLAN attachments distributed across those connections. It requires control plane redundancy with at least 2 cloud routers. And finally, it requires the entire architecture to be stitched together with global dynamic routing within the VPC. By understanding these official requirements, we can confidently identify the correct set of options to build a robust and highly available hybrid network connection. Let's now explicitly state the final answer to the question. Thank you for your attendance. Please consider subscribing to the channel. Thank you.